Now for this part of the question then, we've got y equals e to the 2x sec 3x and asked to find dy by dx. So how do we do this? Well, what we've got is essentially two functions of x. We've got e to the 2x being multiplied by another function of x sec 3x, and to do this, because we can't expand this out, we need to use the product rule. And if you're unfamiliar with the product rule, here it is. Okay, the product rule is if you've got two functions of x, let's say u and v, being multiplied together, we've got u, if you like, is e to the 2x and the v is sec 3x, then dy dx equals u times dv dx plus v times du dx. In other words, all you do is you take one part, let's say u, times it by the differential of the other part, and then plus, and you just do it the other way round. Okay, take one part and then times it by the differential of the other part. Okay, so that's what we're going to do here. So let's start off then that we've got dy by dx, therefore dy by dx is going to equal, well, I'll tell you what we'll do, we'll label this u, if you like, and this is the v part. Normally I wouldn't label those in red, I'd just leave them and just do it straight off, but it's just there as a guide. So according to the formula, it's u, so that's going to be e to the 2x. Now do put everything in brackets, okay, because you might end up with ambiguous statements, so I'd always encourage you to put each part in a bracket. Now we need to multiply by the differential of v. We need to find dv dx. Now this is where the first part of the question comes in, because if you remember, we were basically given that if you differentiate with respect to x, say sec x, they gave sec x as the example. I'm going to change that to sec theta though, okay? I don't want it to clash with the x that we've got here. If you differentiate sec theta with respect to, whoops, I've got x here, I should change that to theta, okay? What you get is sec theta tan theta. They obviously gave us this to help us on our way through this part here, because we've got to times now by the differential of sec 3x. Now you'll notice we've got a 3x instead of, say, an x, or a theta if you like, okay? So what we've got to do is use the chain rule. So think of this as theta if you like here, sec theta. You differentiate sec theta with respect to theta and you'd get sec theta tan theta. But everywhere there's a theta, it's now a 3x. So you're going to get sec 3x times tan 3x. But because we're using the chain rule, we're calling this theta, you need to times by the differential of theta. So you differentiate 3x and you get 3. Okay, so put a 3 there. Okay, so using the chain rule then, that's the differential of sec 3x. So we've done this part of the product rule. Now we've got plus and we've got v, so we just put the other part down, sec 3x. Put this in brackets as well so we don't create any ambiguous statements. And we now need to times it by the differential of the other part, du dx. Well, this is the other part here. U is e to the 2x. We need to times it by a differential of e to the 2x with respect to x. So again, we use the chain rule. Differential of e to the t, if you like, is e to the t, so that's e to the 2x. And we need to multiply by the differential of t with respect to x. We differentiate the 2x and we get 2. Okay, so hopefully you're okay with the chain rule. Now that we've got that, essentially we found dy dx. It's just a question of cleaning this up. So what I'd encourage you to do is take the first term and rewrite this. Rewrite this as 3 first of all. Then you've got e to the 2x, and then you've got your trig functions in here, sec 3x, tan 3x. That's the first term. Now we come on to this second term. Here, put the number first, then the exponential function, then the trig function. Normally that's the best way around to do this. Okay, so we've got plus 2 times e to the 2x sec 3x. Alright? Now, what you could do is notice that you've got in both of these terms a common factor. You've got common factor of e to the 2x, it's here and here, and you've also got sec 3x. Okay, so you could pull this out as a common factor. E to the 2x, I should say, and sec 3x bracket, and then for the first term you've got 3 tan 3x, and then for the second term you've just got plus 2. So there you go, dy by dx for you.